6, part B. Find the value of W in this situation. And now we've got a new variable x, random variable, which is distributed normally with a mean of 21 and a standard deviation of 5. And we record it in as 5 squared so that we have the variance there of 25. Okay, and now we've got to find the value of W such that the probability that x is greater than W, given that we know that x is greater than 28, is 0.625. So job number 1 is to understand what this says, because it looks complicated. In fact, it looks a lot more complicated than it is when we think about it. So we use a diagram to get our heads around what's happening. So here's a diagram for my x data, which is distributed normally. Before I worry about what all this means, I put on what I know. I know that the mean is 21, and I know that the standard deviation is 5. And I know that almost all my data disappears by the time I move 3 standard deviations away from the mean. So if I add 5, I get to 26. Add 5, I get to 31. Add 5, I get to 36. So at about 36, there's really none of this random variable x takes values over 36. I can follow that pattern backwards. I would get 16. Take away another 5 would be 11. And take away another 5, I'd get to the end of pretty much my data, and I would get to a 6. So this is what the distribution looks like. Now, the next thing to do is go to the given section of the probability. It says, given that x is greater than 28. So we're not here now. We're not out of 1. We're not out of this whole proportion. We're out of x being greater than 28. So 28 would be about here. So considering that the area is what tells you about the frequency of the different things that are happening and how many things are in each situation, if we're saying given that x is greater than 28, then we're narrowing ourselves down to being in that section. So when it says given x is greater than 28, they're saying given that we're somewhere in here, our value of x is somewhere in here between 28 and 36. Technically anything over 28, but realistically there'll be almost no value of x that's greater than 36. Almost all the data is within 3 standard deviations of the mean. So now let's see what it's saying. Given that you're in this section, the probability that x comes out more than some value w is 0.625, as in just over 60%. So it's asking me to find a value of w in here where the probability of being greater than that number, w, given that you're in this section, is just over 60%. So normally when we have probabilities of, say, 60%, we'd be looking in the whole table and we'd say, well, 50% is about there. So if you wanted the probability of being greater than something to be 60%, you'd want to pick something on this side so that when you put the marker in, all of that greater than section bit could be 60%. But this time we're narrowing down to being in here, and we're saying that whatever number we pick, out of this area, we need to find a 62.5% section, just over half a section. And so I'm going to go for something like this, that if that bit is 62.5% of this section, then this is the missing number w that I want. That the probability that x is greater than w is 0.625 out of this section. So now, how do we actually go on to solve this problem? Well, we can't really do anything with probabilities when we're in X land, so we need to get ourselves standardized into Z land. And the standardized graph works like this. So first of all, I'm going to take my 28 and standardize it. I'm going to standardize it by subtracting the mean, 21, and dividing by the standard deviation of 5. Now 28 minus 21 divided by 5 is 1.4. So what can I do with this now? Well, I can look up 1.4 in the Z tables and I can find out what probability that gives. And it is 0.9192. Of course, it's reading from the left. Now, I'm really only interested in what's going on over here. So I can now do 1 take away 0.9192 to find out that this probability here is 0.0808. So there's actually only about 8% chance of being in this section. But we're interested in just this part. Now, this part is 62.5% of this. So the way that we're going to find this section here is we're going to do 0.625, 62.5% of this number. And that's going to tell me that shaded section there. So that's 0.625 multiplied by the answer. So that's 0.0505. Okay. Well, that will allow us now to find W, although we can't read W from the X. So instead, actually, we're going to use this number on this chart to find out this Z value. So I'm going to go back to my tables, look down the probability column. I can't look up this directly though, so I'm going to have to do 1 take away 0.0505, which gives me 0.9495, so that I can look up from this direction what this number would be. And can I find it? 0.9495 is happening at 1.64, which looks right, a little bit higher than 1.4. And now, if I can transform that number back to W, then I will know what my W value is. So I do that by undoing take away the mean, divide by the standard deviation. I do the opposite. I take my Z value and I multiply by the standard deviation, and then I add on the mean, and that should get me to a value for W. 1.64 times 5 plus 21 makes 29.2. And it looks right, a little bit higher than the 28 there.